Hi everyone, in this video I'm going to show you how to fill in missing raster values using R. If you want to learn more about R, I post videos every single week, and I've also provided the link to the data we're going to use today in the description box. So let's get started. The first thing I'm going to do is set my working directory. Okay, so now my R script knows where to look for my data. And now we're going to import the libraries that we need. We only need one library, the Terra library. So let's go ahead and import that. And as usual, I always say that if you don't have the library installed, you can install it using the install packages function. It looks like this. And then you would just type in the name of the library that you want and then click enter. But I'm not going to do that because I already have it installed. So next we can go ahead and import the raster that has the missing data. Let's use the rast function. I'm going to call my raster sample ras, and then we'll use the rast function to import the raster. So you type out rast, you use quotation marks, and then in the quotation marks you can name the raster. So my raster is called sample ras.tiff, and click enter. So let's take a look at this raster and see what it looks like. I'm going to use the plot function, plot sample ras. Let me zoom in a little bit. Okay. So you can see here, there's quite a bit of missing data. All those white lines are artificial lines. They should not be there. And it just makes the raster look extremely disjointed. And you can see that some of these green areas, they should most likely be solid green areas. And because of these white lines, it's just awkwardly cutting up the data that we have. So I'm going to use a couple functions to fill in these gaps. Well, actually, it's just one function. It's a function called focal. It's from the Terra library. So let's take a look at the function. I'm going to do question mark and then focal, enter, and then you see details on how the function operates. So we're gonna type out focal brackets, and then in the brackets we would need a couple arguments. So first we need the name of the raster, so the spat raster for X. Our spat raster is called sample ras. Then we need to provide a window, so that's W. Let's do W. So the window is essentially where your missing values are going to come from. I'm going to do, there's two options. You can provide a single number and use that number to represent a square. So if we have W equals 3, it'll be a 3 by 3 squares, which means 9 raster cells, and it'll take the values from those cells to estimate your missing cell. Or if you don't want to do a square, you can do two numbers that represent rows and columns. So if I wanted to do only 2 rows and then 3 columns, I can do a two number vector. But I think that we should just keep it simple. We'll set W equals 3 and create a 3 by 3 moving window to estimate our missing cells. We also need to provide a function, which is what fun stands for. Let's do that. And this is where you tell the focal function to calculate. Do you want to take the average of the surrounding cells of the cells in the window? Do you want to take the maximum number of cells? What do you want to do? So we are only going to do the average. We're going to keep it very simple. So I'm going to do fun equals mean. And then finally, we're not gonna bother with the other arguments. We're only gonna add one more argument, which is NA policy. So let's type that out. And this is a really important argument because for this example, I only want to fill in missing values. I don't want to be messing around with values that are already there. I only want to fill in those white lines that were in my raster. So you have a couple options here. If you want to replace all the cells with some calculation, you can click all. Or if you only want to fill in cells that are missing, you can click only, or you can type out only. So I'm going to do NA policy equals only. Let's save this to a variable called newras. I'll change this one too. It doesn't really matter what you use as your equal sign, but we'll change it. And then let's run the newras. And let's take a look at that as well. So plot new.ras. And there you go. Let's zoom in again. And you can see here that all of our missing cells have been populated with values. And the values are obviously the mean raster cell of the surrounding 3x3 window. If you want more details on that, I'll be uploading a course on how to use R for GIS and spatial data science. And I'll go into a lot more detail on what we mean by moving window. But you can see the final raster here. I think it looks great. So let's save the raster now. We're going to use a function called write_raster. Again, this is from the Terra library. We're going to input the name of the raster that we want to upload, which is newras, and then we'll give it a name. I'll keep it simple, newras.tiff. Okay, and it'll save to wherever your working directory is. Mine is a folder called sample data, so it'll be saved in that folder. And again, if you want to try this yourself, the data is linked in the description box. Let's do one more example of what happens if we change the moving window. So let's copy this function here, the newras function. We'll call it newras.to, and then we'll change the moving window to something kind of extreme. So let's do 30 or even 31 because it has to be an odd number. Let's click run and we'll plot that. Plot newras2. So this is interesting. You can see that, let's zoom out. There we go. It's taking so here's the new raster2 with a moving window of 30. And you can see that it creates a lot of awkward edge effects with the moving window. And it's taking the average cell value of a 31 by 31 moving window, so a very wide window. And it's actually capturing some of the artificial grid lines. And you can see that the missing values are becoming a lot more transparent, and it's not actually interpolating appropriately for the type of data that we're working with. It's taking the average of a pretty wide window, and so you're getting an inflated value that doesn't represent the value that this most likely is. So it's important to think about this when you're picking your window, and of course the value of the window will change based on the type of data you're working with. And so you need to have a solid understanding of the type of raster data you're working with and what would be appropriate as a moving window or as a window size. So that's another example. I'm not going to save this one because this example is not, it's not a reasonable output, but I just wanted to show you how the plot would change if we were to pick a more extreme moving window. So that's that. I'm going to end the video here. And again, if you want to see more videos like this, feel free to subscribe. I post videos regularly, all on programming and working with spatial data and non-spatial data. So yeah, good luck and let me know what you think.